Well, hey guys. Was originally going to the assignments for the year document, but I just finished the MrFieldMath.com. I don't know why the videos load so slow. Well, I mean, I kind of know. All right, so this was the last week. So now this week, see, we're making the video right now. Returning to functions, unit 8. So we're going to talk about shifting, scaling, absolute max and min, positive negative intervals, increasing, decreasing. All right, so what should we start on? The shifting. Okay, so this was the number one missed question out of the few people that have done this so far. So when we are talking about shifting the parabola, we are not changing the shape. We're not looking at the A value, only looking at, like the vertex form. So we know vertex form is like this, right? But did you ever think about that H as being the left, right shift? Because it is. And then the K is the up down shift. And these are shifts of the basic function, which is our friend x squared, the basic function. So we're taking that graph and, when we're scaling and reflecting it, we're changing the size and changing the concavity. But for this assignment, we're just moving it. We're not even changing the shape. So what you got to ask yourself is, starting at F and moving to G, did it go up or down? Well, we know, hopefully, look at the vertex, right? Because we're talking about vertex form here. And so it is only going down 1, 2, 3. So that would mean that g of x is the function x squared, no parentheses because we're not moving left to right, minus 3. And that's it. So let's see if we can find the left-right shift. Maybe 2 shifts. All right. So this one we're going down 1, 2, 3, 4. So down 4. We're also going over 1, 2, 3 plus 3. But we know that it's the opposite for the left-right shift. Did you remember that? And then we're going down 4, so that is not the opposite. So this graph would look like this. And this is the right by 3, and this is the down by 4. All right, so that's the shifting. Now let's go to the scaling and the reflecting. So this right here, 2 people have answered incorrectly, is a reflection, but it's also a scale. So we see the original graph. Oh no, there we go. The original graph has the equations, we do -3, -2, -1, 0, 1, 2, 3, just for some points. All those are squared, so it would look like that. All these numbers are the squares of the x values. And so if we see 3, -6, well, that doesn't fit. It's supposed to be 3, 9. So, but then we also see it's reflected. So the question is, how can we go from 3, -6 to, how can we go from 3, which would originally have been 3, 9, and then move it over to 3, -6. So what do we have to do? What can the A value be to x squared to create that. So we know, and then we know that the y is, okay, so this is the question, right? What is our a value? And so we can substitute in our point and we can solve for a. It's going to be no problem. So I'm going to put in the -6. I'm just now thinking of this. And then I'm going to put it in the 3. And we know it's squared. So that's 9 times a. And I'm going to divide both sides by 9. And we get -6 over 9 is what a is. But that reduces to -2 over 3. Let's see. Is that the right answer? So my thought here is that y equals, or g of x equals, and we better not write the y equals, just that g of x is -2/3 x squared. And it fits because it opens down so that it should be negative and 2/3. So it's not quite doubling or anything. And lo and behold, there it is. Should we try another one? Let's try another one. All right, so 2, -1. Oh no, I can see the answer. That's all right, I'm just gonna do my same way. So we have our point, we know y equals x squared is our basic function. And we're gonna substitute that point in, -1. Oh, but we know that there's gonna be an a value. And we don't know what it is. So we're gonna put the y equals ax squared. And so we just solve that equation. So that's 4a equals -1. -1 over 4 equals a, and that's what we see here. Okay, so substitute your x and y into the equation y equals ax squared, solve for a. It'll be great. You'll have a lot of fun. What's the next assignment? Absolute max and min, according to Mr. Field Math. So here we go. Oh, this one was pretty simple, right? So we did relative max and min, which was the relatively high points in a certain region of the graph. But absolute has to be the highest point or the lowest point, and not all functions have them. For example, a linear function has no absolute max or min because it goes up forever. It goes down forever. There's no absolute lowest point, no absolute highest point. Infinity is the word of the day for linear functions. But for some other functions, you do have maxes, absolute high points. Like this one right here, there's no other point on the function that goes higher than 6. So its absolute maximum is 6. And you can have an absolute minimum. This one has an absolute minimum at -5. Moving on. Positive and negative intervals. So with this one, we really want to make sure we know we're talking about the y values. So write this title in your notes and then write, we're talking about the y values. So where is this graph positive? Where are the y values positive? That only happens between -2 and 0. So we use our x values to write the interval. Use x values to write the interval, but use y values to determine the interval, like the interval's location. Let's say that interval's location. So the y values are positive right here. And that happens between -2 and 0. So that's what we want to look for. -2 and 0. Now I see -2 and -1, and that's also true. -2, between -2 and -1 is a positive interval. It's not the whole thing, but it is a positive interval. So that's the choice. Of 0 and 1. Am I looking for the negative interval? How did I read that wrong the whole time? All right, well, you get the idea. All right, let's do another one. Okay, let's read, Mr. Field. F is positive. It does say positive, right? Okay, so F is positive here, here, and here. So 3 positive intervals. So I don't know what number this is. Let's say it's -4.7. Let's say that's 4.7. And let's say this is 1.7, -1.7. So the full thing would be it's positive, or we can say the positive intervals are when x is less than -4.7, when it's between -1.7 and 1.7, and when x is greater than +4.7. So if there's any smaller intervals, then we can choose like -1 to 1. Well, yeah, -1 to 1 is positive. That's within the interval -1.7 to +1.7. So you could do it. Have fun with that one. And some of your classmates have already earned 100% in it. And the last assignment, increasing and decreasing intervals. So now this one, we're talking about the slope. Increasing, positive slope. Decreasing, negative slope. Now it's not a line, it doesn't actually have a slope, but what we do is we talk about these things called tangent lines. So a tangent line is a line that intersects the graph at just one point. You see, so like I'm trying to make it intersect the blue graph at just that one point. These things are really important. They come back in a big way in calculus. You'll see them in geometry too, just briefly. And so, tangent line. So what's the slope of this line? It's positive, right? M equals who knows, but we know it's positive. So for that reason, this is an interval of increase. And then this over here, if I were to draw a tangent line, you can see it would be negative going down. And then what about right at the bottom here? Straight across, you can see that right at the absolute minimum, there is a slope of 0. So that's when it changes from negative to positive, right at that minimum. You see how it's all coming together now. So now let's answer the question. Select the intervals where g is increasing. Between -5 and -2, -5 to -2. No, the graph is decreasing that whole time. Okay, what are my other choices? -2 to 0? No, the graph is decreasing. 2 to 5. Okay, 2. Yes, it's increasing. 2 to 5. 2 to 5. There it is. All right, well, I think that's good. And so now go forth and earn 100%.